So, for the general standard form of an ellipse, we have two arrangements, where we either have x minus h quantity squared over a squared plus y minus k quantity squared over b squared equals 1, where we're talking around center hk, and we're looking at a horizontal major axis, just not built around the origin anymore. It's built around a more general point where our vertices and foci have to talk in terms of the distances a and c away from that coordinate h. Similarly, we have x minus h quantity squared over b squared plus y minus k quantity squared over a squared equals 1 for an ellipse centered at hk that is oriented vertically. So in that case, our vertices and foci are going to be given in terms of the distances a and c away from the coordinate k. And to better understand how these equations work, we're going to look at another example, where for this example we want to graph the ellipse given by the equation x plus 1 quantity squared over 9 plus y minus 2 quantity squared over 4 equals 1. Where the first thing you want to notice is what form we're in, where we have the larger coefficient, as it were. We have the larger value attached to a. We have that 9 there. So we will have a horizontally oriented ellipse with center at the point -1, 2, based on the fact that we have h equals -1 and k equals 2 for this pattern. Then we will have that a, the value squared underneath x in this case, is 3, and c, for similar reasons, is equal to 2. So if we want, or not c, excuse me, b, getting ahead of myself, is equal to 2, and we can use that to get that c is going to be equal to the square root of 9 minus 4, or c is plus or minus root 5. And that tells us a bit of information about our vertices as well as the points along our minor axis. And then if we want to see them, we can also think about the foci, but we're not going to worry as much about that here because we're trying to make the shape. So to get our vertices, the points along our major axis, what we can do is take our center and understand that because we're using a horizontal arrangement, we want to take that value a and then add it and subtract it to our x coordinate. So if we're working in terms of that x coordinate and we subtract 3, we will get -4, 2 and +2, 2. Meanwhile, if we want to get our points along the minor axis, I'll just abbreviate that by calling it minor. We'll take the value b and do the same sort of thing with the k coordinate. So for that, when we subtract, we will get -1, 0, as well as -1, 4 for when we add. So we have these 4 points, and based on the arrangement that we have with them and our greater patterns that we've seen, we will end up with a graph something like this, where we have that horizontal ellipse shape built around those 4 points with the center in the middle of them. And the last thing we're going to do here, the last thing we're going to see from this section, is a way that we can apply these elliptical concepts into a real-world, albeit somewhat finagled example.